there folks, Dr. Saul, the solving surgeon, back talking to you about proportions and similar figures. Now here's a question. Why did the doctor say not to worry about the bird flu? Because it's tweetable.
First vocabulary term is a ratio. That's a comparison of two quantities using division. So here you see we have A over B, or A to B. We have 3 to 4. We have 50 miles per every 1 hour, or 50 miles over 1 hour. And here we have $20 per pound, or $20 for every 1 pound. Those are a bunch of different ways to write ratios. A proportion, that's a statement that two ratios are equal. So here you see we have A over B is equal to C over D. These two ratios set equal to one another creates a proportion. The cross product property is a method for solving problems involving proportions. So if you want to solve a proportion, you use the cross product property, which says A times D is actually equal to B times C. You multiply across and set each of those products equal to one another. That is the cross product property. Now, a scale drawing is the use of a ratio to compare each length in the drawing to the actual length. So what happens is in a map, you are given a scale. Because obviously you can't hold a map that is the size of Georgia, what you need to do is scale it down. So it gives you this scale, which says 1 inch is equal to 250 miles. So you can measure on your map, and however many inches that is, you can then calculate how many actual miles it is based on your scale. Now let's talk about similar figures. So two polygons are similar if and only if their corresponding sides are proportional. Let's first talk about corresponding sides. What are corresponding sides? Well, there's two ways to look at corresponding sides. One would be through the figure. If these are similar figures, then I know AB corresponds with EF, BC corresponds with FG, CD corresponds with GH, and HE corresponds with DA. Now that's not always the case. Sometimes they'll flip one of the figures to trick you. You can always look at the similarity statement. So the similarity statement right here, this says quadrilateral ABCD is similar to, that's what this little tilde means, quadrilateral EFGH. And you know, AB corresponds with EF, BC corresponds with FG, CD corresponds with GH, and AD corresponds with EH. These are not in a random order. They are specific order so that you know which sides correspond with one another. Now, down here, you can see I can create a proportion based on these corresponding side lengths because these two are similar. So I can say the measure of AB over the measure of EF has to be equal to the measure of BC over the measure of FG. And why is that? Because two polygons are similar if and only if their corresponding sides are proportional. So if I were to set up these two ratios and simplify them down, they would be equal to one another because these two figures are similar. Same thing over here.
What did the doctor tell their patient who was addicted to Family Feud? Well, the survey says... It's example time.
Okay, example 1 says given the following trapezoids where trapezoid ABCD is similar to trapezoid AFGH, complete the congruence and proportion statements. Two ways to do this. One would be through the figure, the other would be through the similarity statement. We're going to start with the figure. So let's look at the figure. Here we have AB, which is the left side of the large trapezoid, over AF, which is the left side of the small trapezoid, is equal to BC, which is the top of the large trapezoid, which means that would be over the top side of the small trapezoid, FG then. You could also do it from your similarity statement. If you're given a similarity statement, that's probably the easiest way to do it. AB over AF has to be equal to BC over, now where's BC over here? Where's the two middle ones? That would be FG. Here, we'll start with the figure. GH, the right side of the small trapezoid, over CD, the right side of the big trapezoid, is equal to AH, the bottom of the small trapezoid, over, and it would be the bottom of the big trapezoid, which would be AD. Again, you can do that from your similarity statement. GH is right here, over CD, the back two, is equal to the outside two, AH, over the outside two, AD. For part C, we have FG over blank is equal to BC over AD. We'll start with our figure. BC, where's BC? BC is the top of the big trapezoid. AD is the bottom of the big trapezoid. Okay, so we have top of the big over bottom of the big. So this side should be top of the small over bottom of the small. So top of the small trapezoid would be FG, yep, over bottom of the small trapezoid, AH. And again, similarity statement works too. So FG, the two middle, over the two outside, has to be equal to the two middle over the two outside.
What happened to the optometrist who got stuck in the lens machine? Oh man, it was a spectacle. You try.
Okay, we're doing the same thing. Here, this time we're given triangles, and this is our similarity statement. So let's go ahead and do this. We'll start with our figures. XY over LM. So XY would be the left side of the small triangle, and LM would be the, well, how does that work? This time we might have to rely on our similarity statement because we have two flip figures, so they don't actually match up. XY over LM, so XY the first two over LM the first two is equal to YZ the last two over, it should be MN the last two. Boom, done. Here, NM, the back two over ML, the first two, has to be equal to the back two over the first two, so ZY over YX. And then lastly, we have XZ, the outside two over something is equal to YZ, the back two over MN. The back two for our second ratio right here. That means that in the first one, the outside two would be over the outside two over here, L and N, so it would be LN. Now example 2 says the figures in each pair are similar, find the missing length. So here, we have two similar figures. How do we find our missing side length down here? What we need to do is we need to set up a proportion and then solve for our missing side length. How do we set up a proportion? Well, we just had a bunch of practice doing that. We need to find our corresponding side lengths. So here you can see that KL corresponds with NM, NO corresponds with KJ, and JL corresponds with OM. So what we can do now is set up a proportion based on those corresponding side lengths. We do it a couple ways. What I did when I set up my proportion, I did KL over JL is equal to NM over OM. Now that we do that, we can plug in the given values. 9 is going to go in for KL, 12 is going to go in for JL, 6 is going to go in for NM, and A is going to go in for OM. Now, I have a proportion. In order to solve a proportion, you use the cross product property. So we're going to multiply across. 9 times A is equal to 6 times 12, and you end up getting 9A is equal to 72. Now all I have to do is solve this. So in order to solve, we need to get all the variables on the left done. Constants need to go to the right, so this 9 has to go over here. How do I do that? Since it's 9 times A, I do the opposite, the inverse. I divide by 9 on both sides. These cancel out. I'm left with A is equal to 8 yards. Make sure your answer has units on it.
What did the English teacher tell the doctor who was listing serious medical conditions? You forgot a coma. You try.
Okay, again, we have two similar figures, so in order to solve this, we need to set a proportion and solve. I'm assuming that AB corresponds with EF and AD corresponds with EH. So a couple ways you could set this up. You could go AB over EF is equal to AD over EH. You could go AB over AD is equal to EF over EH. One of those ways should work. I did AB over EF is equal to AD over EH. Now I plug in the given values, and from here, I can just use the cross product property, multiply across. 3 times 4 is going to be equal to x times 2. Now I can get x by itself. Remember, we need to simplify, move, solve. So we simplified. We need to move variables to the left now. So we're going to flip the equation. We need to move constants to the right. So this 2 has to go over here. In order to do that, I do the opposite, the inverse, because it's multiplied to x. I divide both sides by 2. These cancel each other out, and I get x is equal to 6 feet. Again, don't forget units. Example 3 says, given triangle ABC is similar to triangle DEF, find the measure of AC. So we are given that these two triangles are similar. This will help us set up a proportion and solve. So let's do that. I'm going to go with AB over DE is equal to AC over DF. Now I plug in the given values, and when I do, I see that I have to cross multiply. So I'm going to use the cross product property. Here's the thing that everybody messes up. When you multiply 20 times this quantity down here, put that quantity in parentheses. Same thing up here, 7 times this whole thing. So make sure that whole thing is in parentheses. Now you know you have to distribute. So I'm going to distribute the 20 to the 3x and to the negative 2. And I'm going to distribute the 7 to the 6x and the 8. 20 times 3x is going to be 60x. 20 times negative 2 is going to be negative 40. 7 times 6x is 42x. And 7 times 8 is 56. Now I have an equation. So I simplify, move, solve. Can I simplify either side? Nope. So variables got to go to the left, which means this 42x has to go over here. So since it's positive 42x, to move it, I do the opposite. I subtract 42x from both sides. These cancel each other out, and I'm left with 60x minus 42x gives me 18x. Now, I have my variables on the left. I need to move my constants to the right. So this 18 has to go over here. How do I do that? Since it's 18 times x, I do the opposite, the inverse. I divide by 18 on both sides. These cancel each other out. I'm left with x is equal to 96 over 18, which simplifies down to 16 thirds. A lot of you would box this as your answer and call it a day. But look back at the question. Make sure you answer the question. It says find the measure of AC. This is the measure of X, not AC. So what I do is I take this value and plug it in for X in what AC equals. The measure of AC is 6X plus 8. So I need to take this value and plug it in for X, and now I can solve this. So 6 times 16 thirds. How do I do that? Well, 6 is the same as 6 over 1. So it's just multiplying fractions. Multiply the 6 to the 16 and the 1, the imaginary 1 down here, to the 3. You end up getting 96 over 3, which when you divide 3 into 96, you get 32. That's nice. So when you add these together, you get a measure of AC is equal to 40 feet. Don't forget units.
You want a lollipop? You try.
Here, we're given that A, B, C, D is similar to E, F, G, H, and we want to find the measure of E, F. So again, we are given a similarity statement, so we got to use it. AB right here corresponds with EF, which would be this guy right here. What else are we given here? We're given BC. What does BC correspond with? FG down here. Cool. So what we're going to do then is we're going to set up a proportion based on those facts. You can set it up a couple different ways. You can go AB over BC is equal to EF over GH. You can go AB over EF is equal to BC over GF. Either way, you end up getting the same answer. So we're going to set up a proportion. When I did it, I got AB over EF is equal to BC over GF. You could have done it the other way and still got the same answer. So when I plug stuff in, use the cross product property. Remember, you're distributing this 6 to the whole thing in our numerator, 5y minus 4. And then this 9 is going to distribute to the 3y and to the negative 1. So down here, I distribute 6 to the 5y and to the negative 4. 9 goes to the 3y and to the negative 1. So we multiply that all out. 6 times 5y gives me 30y. 6 times negative 4 gives me negative 24. 9 times 3y is 27y, and 9 times negative 1 is negative 9. Sweet. So I simplified. Now I need to move. Move variables to the left. How do I do that? Well, this positive 27y has to go over here. So since it's positive 27y, I do the opposite. I subtract 27y from both sides. These cancel each other out, and 30y minus 27y gives me 3y. Now the constants need to go to the right. Start with anything added or subtracted to our variable we're solving for. So this negative 24, how do I move it? Do the opposite. I add 24 to both sides. These cancel out. I get 3y is equal to, what's negative 9 plus 24? That's positive 15. And then lastly, to get y all by itself, I move my last constant to the right. Since it's 3 times y, I do the opposite, the inverse. I divide by 3 on both sides and get y is equal to 5. Make sure you answer the question. It wants you to find the measure of EF. So EF is right here, which means we're going to take this guy right here and plug in what we just found y to be. So if the measure of EF is equal to 3y minus 1, and we know y is equal to 5, we plug in 5 for y. We multiply 3 times 5 first, and then we subtract based on order of operations. We get the measure of EF is equal to 14 inches. Don't forget units. Word problem. This says, using the map and the ruler below, what is the actual distance from Beijing to Shanghai in kilometers? So down here, we know 1 inch is the same as 400 kilometers. So now what we need to do is take this ruler and measure the distance from Shanghai to Beijing, or Beijing to Shanghai. So let's go ahead and do that. What's the distance from Beijing to Shanghai? Well, it looks like it is 2.5 inches. So we know it's 2.5 inches from Beijing to Shanghai. And we know that 1 inch means 400 kilometers. So we need to set up our proportion. 1 inch to 400 kilometers is equal to 2.5 inches over blank. Inches to kilometers equals inches to kilometers. So now let's figure out what the actual distance is. So how do I solve a proportion? Cross multiply, cross product property. X times 1 is just going to give you X, and 400 times 2.5 is going to give you 1,000. So we know that X is equal to 1,000 kilometers. That is not your answer. What you need to do is answer the question. What is the actual distance from Beijing to Shanghai? In kilometers, you would say, according to the map, the distance from Beijing to Shanghai is approximately 1,000 kilometers.
Oh man, this is not looking good. You should try.
Now, word prompt says, when Dylan, who is 6 feet 1 inch tall, stands next to a basketball hoop, his shadow is 4 feet 2 inches long, and the basketball hoop shadow is 7 feet 4 inches long. Find the height of the basketball hoop. Round answer to the nearest inch. So let's label our figure down here. Dylan is casting a shadow, as is the basketball hoop. We know Dylan is 6 feet 1 inch tall. We also know his shadow is 4 feet 2 inches long. We know the basketball hoop's shadow is 7 feet 4 inches long. long. And we want to figure out what's the height of the basketball hoop. So we'll call that x. That's what we're trying to find. So how do I do that? Well, this is where that indirect measurement comes in. These shadows created by two perpendicular objects to the ground create two similar triangles. So what we can do then is set up a proportion between these two similar triangles and solve for our missing height over here. So how do I set up this proportion? Well, I can just go Dylan's height over the height of the basketball hoop is equal to Dylan's shadow length over the length of the basketball hoop shadow. Now all I have to do is cross multiply, solve for x. Oh, how do I multiply these together? Well, I can't have feet and inches in my proportion. So what I'm going to do is convert each of these to inches only. How do I do that? I just multiply the number of feet by 12 and then add however many inches there are. So 6 times 12 plus 1, that is going to be 73 inches. 4 times 12 plus 2, that's going to be 50 inches. 7 times 12 plus 4 is going to be 88 inches. Now that I've converted to inches only, I can actually solve this proportion. So how do I solve this? Well, I need to use the cross product property. I'm going to multiply across and set the two products equal to one another and solve for x. So x times 50, I'm going to set equal to 73 times 88. Now, how do I solve for x here? I'm going to divide both sides by 50, and then I end up getting that x is equal to 128.48 inches. Sweet. Now, this says round to the nearest inch, so you could technically put 128 inches and call it a day, or if you want to do a little A+ work, you could see that all the other measures here are given in feet and inches. So we can convert this to feet and inches. How do we do that? Well, we take the number of inches and we divide it by 12. That'll give us the number of feet. So there are 10.706 repeating feet in the height of this basketball hoop. So we know the basketball hoop is 10 feet tall and then 0.706 of a foot tall. Well, 0.706 of a foot, we just multiply that by 12 and that'll tell us how many inches there are in that much of a foot. So if we multiply these two together, we get approximately 8.48 inches, meaning the height of the basketball hoop is approximately 10 feet 8 inches tall.